I just want to see LabVIEW users succeed. I just want to see LabVIEW adoption grow. I just want to see LabVIEW users get unstuck when they have problems and have a seamless experience when they use the editor.
Welcome to the LabVIEW experiment. I am your host, Sam Taggart from SAS Workshops. In my 15 years of working with and training developers, I've had the opportunity to conduct a lot of experiments. Over here, we believe in embracing failure as the essential learning experience that it is. And what better way to learn than from other people's mistakes? In this podcast, I talk to industry experts, colleagues, and friends about their failures and how they have turned them into future successes. All right, I am here at NI Week with DNatt, or Darren Nattinger.
Thank you for saying my last name correctly.
Yeah. Okay, great. Thank you.
Everybody says it with a soft G, but it's a hard G. So I've
cool.
probably corrected you in the past.
Probably. That's probably how I know. Yeah. So for those of you who don't know Darren, he has worked at NI for quite a while in the R&D department and various other things, which we'll get into. And let's see, what is it? DNatt.org is the website.
Yeah, so if we want to start with that. So one of my passions for the LabVIEW community is sharing information about all of our favorite programming language. And one of the ways I've done that historically is through presentations at various events like NI Week, NI Connect, GDevCon, GDevCon NA, GLA Summit, VI Week, which we had during COVID. So I like to present on LabVIEW. I like to present on a variety of different topics. And most of my presentations are practical and tactical in nature. My desire is that you come away from my presentations with something that you can do in LabVIEW that day. Like you can take what you've learned in my presentation and that day incorporate it into your workflow in some way. And so I've got a lot of presentations on a variety of LabVIEW related topics, and they're all available at DNatt.org. It used to be a harder URL to remember. Then Jorg Hampel kept forgetting what my URL was, and he kind of guilted me into making a better one. And so DNatt.org, you can't get much simpler than that.
Great. That's cool. Yeah, there's a lot of them. There's probably got to be at least 15 or 20.
Not quite, but close.
Okay. Yeah.
Give me another year or two.
Okay. Very cool. Yeah, and they're all, the ones that I've seen, I don't know that I've seen them all. I probably haven't because there's a lot of them, but they're very good. And as you said, very practical, good advice. So
yes, in fact, we're doing this right now, right before NI Connect, and I will be NI Connect 2023, and I'll be presenting my Introduction to DQMH presentation at NI Connect 2023.
Yeah, well, and on top of presenting so often, you're also a very popular presenter because you get lots of good remarks and stuff. And you and Norm put together a presentation on how to be a good presenter, too.
We did, yeah. He and I have so much material, follow-up material for that presentation. So we gave that presentation at GLA Summit 2022, Become the World's Third Best LabVIEW Presenter. That was the title of it. And we have so much follow-on material that we have just had no time to put together, but we've got all sorts of ideas for a sequel for that. So hopefully at some point when we both get some more time, there will be a lot more material coming out, helping LabVIEW programmers become better LabVIEW presenters.
Great. That's really cool. So do you want to talk a little bit about your history at NI and your background and like...
Certainly. Yeah. So I attended college at the University of Texas at Austin here, and my degree was in mechanical engineering. And I was about to graduate, and I was looking for a job. I was newly married, and I really, really loved the Austin area. I wanted to stay in the Austin area upon graduating school. And so I was interviewing for jobs, and NI, obviously here in Austin. And I interviewed for a couple of jobs at NI. One was in the manufacturing department, and one was in a department that they had at the time called ELP, which stood for Engineering Leadership Program. They would hire engineers, have them do tech support, learn about all the different parts of NI while doing tech support, and eventually move into other jobs. So that's the job I picked. I've worked in ELP for almost 3 years. And while I was in the department, I worked on projects with a ton of different groups at NI. I worked on a marketing project. I worked on sales projects. I worked on projects with the web team. And ultimately, as I was getting on to my third year in the program, I started working on a LabVIEW development project with LabVIEW R&D. And it was a blast. I loved LabVIEW programming. Obviously, I had been doing some LabVIEW stuff as part of my tech support job. But working on these projects with LabVIEW R&D, really enjoyed it. Ended up getting an offer from LabVIEW R&D and started working in LabVIEW R&D, and this would have been in late 2001, where I stayed for 18 and a half years. So I worked in LabVIEW R&D for a really long time, working on different features of LabVIEW, all based in G. I'm not a text-based programmer. I only know LabVIEW. And so a bunch of, if it is a G-based feature in LabVIEW, I probably worked on it at some point. Report generation toolkit, VI analyzer, app builder, all sorts of pieces of LabVIEW, the tools options dialog, all sorts of pieces of LabVIEW that are written in LabVIEW I worked on. And then in early 2020, right as the world was catching fire, I, for career growth related reasons, decided to move out of LabVIEW R&D and into the tech support engineering department at NI. So I've been there for almost 3 years in a senior role, helping mentor the engineers in the department, helping put together LabVIEW training, helping guide the tech support engineering department at NI to be able to provide better LabVIEW tech support to NI customers. And that's where I'm at today.
Cool. Hey, I have a question.
Sure.
So when you were in LabVIEW R&D, you said you were not a text-based programmer.
Correct.
Were there many other people in R&D who were not text-based programmers, LabVIEW programmers, or was it like mostly C programmers? Or?
It depends on what time period we're talking about. So I was there for almost 2 decades, and in that time, the size of the group of LabVIEW programmers in LabVIEW R&D changed. There were times where there were dozens of us. There were times where there were a few of us, and it just kind of varied depending on what projects were going on and the staffing levels of the department.
Okay, cool. So you mentioned that one of the things that you were into when you were in R&D was improving the developer experience. Can you talk a little bit about that and about what you were able to do to improve that?
Sure. So that's a term that we don't hear as much as user experience. We hear that term quite a bit. Like, how are we going to guide the users of our application? And as you know, Fabiola de la Cueva is a huge advocate of developer experience. How do we improve the experience of the LabVIEW programmer who is using the LabVIEW editor to create LabVIEW programs? And that's always been a passion of mine. And so we're talking about ways to improve, if you launch LabVIEW and it takes a long time to launch, that's annoying as a developer, right? You're sitting there just waiting, watching the splash screen. There's a ton of VIs that are loading in the background when LabVIEW launches, VIs that are part of the project providers, VIs that are part of other sort of internal parts of LabVIEW. So can we figure out ways to get the load time to improve, make some calls dynamic versus static, like things that you might do to improve the performance of your LabVIEW application that you've built with the editor? I'm taking some of those techniques and trying to apply them to the VIs that are running as part of the LabVIEW editor. So many other aspects like that, adding tools to the editor as well. Many of the items that you launch from the tools menu or the edit menu in LabVIEW, those are written in G. I was frustrated with the fact that during a debugging session, I'd set breakpoints all over my code, and then I'd forget where I'd set them and have start running my code and random breakpoints would hit. Edit, remove breakpoints from hierarchy. That's a G-based tool that I wrote that I added to the editor to improve our debugging experience. So lots of things like that in LabVIEW just to help us become more efficient and more proficient and less frustrated as LabVIEW programmers.
Yeah, that's really cool. Do you have a favorite one of those things that you've done?
A favorite editor tool?
Yeah, a favorite improvement that you've made that.
Well, that's got to be Quick Drop, but we're going to talk about that a little bit more later.
Okay, very cool. Yeah, we will definitely talk about that a lot more later. So you mentioned that since you've moved into this new role, your focus has kind of changed a little bit into helping developers get unstuck. Can you talk about that a little bit?
Sure. So, you run into LabVIEW crashes, hangs, errors, VIs that aren't running as you expect. You try to solve those yourself. A lot of those you end up asking NI for help, right? There's different avenues to come into NI and ask for tech support. And we've got engineers that are answering the phones, that are answering the emails, that are posting to the forums. Well, sometimes those issues sort of go beyond the scope of the knowledge of one of our engineers who has been trained holistically on a lot of different troubleshooting techniques for a variety of NI products. NI makes a lot of stuff. They make a lot of software. They make a lot of hardware. We've got a team of great tech support engineers who are helping NI customers who are having issues with those things. But the thing is, being someone who has been working with LabVIEW for over 20 years, I've got this vertical knowledge of that particular product that our tech support engineers with a more holistic knowledge of the product line don't have. And so when we get into one of those situations where they've narrowed down the problem, it's something complex and it's something LabVIEW related, those are usually the issues where I get pulled in. And so I help based on just the knowledge that I have, the troubleshooting tools I have, the workaround tools that I have. If you recall, I presented at GDevCon NA back in July of 2022 about some of the ridiculous ways that I have helped some people solve the LabVIEW issues that they've had. And a lot of times those end up, I'm sure as a LabVIEW programmer, Sam, when you run into an issue, you would love for NI to fix that issue in a future version of LabVIEW. But you're stuck in the one you've got right now. And a future fix doesn't help you right now. And so any sort of workaround or hack or kludge or whatever I can hand you that gets you unstuck and moving along on whatever project that you're working on, that is the role that I'm very largely filling right now in helping the tech support organization get our NI customers unstuck.
Great. So do you have any just kind of common troubleshooting techniques that you like to recommend? Or
Absolutely. The most common technique that I suggest, and this was in my GDevCon presentation, is app builder checkbox roulette. So when you're building your LabVIEW code into an EXE or a DLL or a PPL, honestly, it's almost always EXEs and PPLs that have these issues. There could be errors that pop up. The more complex your project is, the more LabVIEW classes that are in your project, the more malleable VIs that are in your project. Some of those features that have been known to be problematic over the years, the more of those you have, the more likely it is that some strange error is going to pop up when you try to build your code into an EXE or a PPL. And in App Builder, there's a page called Additional Exclusions, which has several checkboxes. Exclude unused amorphic instances, exclude unused library members, disconnect type defs, like all those checkboxes. Now, I'm not saying it should be this way, but I'm saying that this is what works, is sometimes you go in there and you just play roulette and you start checking and unchecking boxes in there and your EXE or PPL will randomly start building. That's the type of workarounds that I help just to get you unstuck today. And then my second step is, will you please share your code with NI so we can figure out what's going wrong and R&D can fix it so that checkbox roulette isn't necessary in the future.
So I have a related question.
Sure.
So I have an application that takes a long time to build. What contributes to a long time to build? And what are some tips and tricks to try to get things to build faster?
So obviously a lot of things could cause a long build time. The number one cause is circular dependencies. So if library A calls VIs in library B, and library B calls VIs in library A, the resolution of those dependencies, the LabVIEW editor doesn't prevent that, by the way. That is one thing that LabVIEW NXG got right. Not very many things that it got right, but one of the things that it got right was the editor itself prevented you from making circular dependencies. You just couldn't do it. Your components would be broken if you did that in LabVIEW NXG. So they cut it off at the pass with the editor. But in LabVIEW, unfortunately, circular dependencies are possible and they're easy and it's hard to find them. A lot of the times it ends up being type defs. Like you've got a type def in a class, and then another class happens to be, linking to that type def, but the previous class is calling a method in the second one. Those type of circular dependencies almost always are the number one cause of long build time. So if you can identify those, there is a tool that exists called the Class Dependency Viewer that the LabVIEW Craftsman put together. And I will be completely honest, I have not used that tool. But that tool, from my understanding, is that it allows you to find circular dependencies in your code. I would love to hear some reports of whether that works or not. But I have suggested that tool.
Because I was going to ask, how do you find them?
Yeah.
I do know that tool exists, and I've looked at it. I have not actually used it.
Here.
I saw the blog post. I know what it is. And
Same here.
Okay. Yeah. So what is the best way to determine dependencies in LabVIEW period? Is it just open a blank project and drop something in? Because that's kind of what I've been doing.
So the dependencies node in the project is really reliable. Yep. I find it to be one of the most useful tools just to figure those things out. And then what I will often do is then immediately go to if I'm not looking at the dependencies node, I'll go to the files view.
And see where it's pulling stuff.
Exactly. It's pulling stuff in that's not in my project folder. What the heck's going on? Exactly.
Okay, so I guess to find circular dependencies, if you thought there was a circular dependency between files, you would drag one in there, see it pulls in the other, and then just flop it?
Exactly.
Okay.
Yep.
And that's like the only way aside from this dependency viewer thing?
I think so, yeah. Okay. And it's one of the more frustrating things that going back to developer experience, it would be great if the editor just kind of told us or prevented us. Like I can think of some times when circular dependencies are valid. There's generally frowned upon, but there's a few times where I can think of where they make sense. But most of the time, it's going to end up causing those long build times you're talking about. Yeah.
Well, one of the tools that I've used to find circular dependencies is anti-doc. Works really well. Because you can look at the DQMH things, but it doesn't really tell you. It just tells you circular dependencies via messages.
Right.
So you can still have type
you have to
defs
study
causing
the arrows.
Problems
yep.
But yeah, looking at the arrows really quickly. Somebody had posted on the forums DQMH forms, their giant DQMH thing. Maybe you saw it was like, I don't know, had like 40
No, I didn't
things
see
in
that.
it. This is like a few months ago.
Okay.
But it had obvious circular dependencies in it. They're like, why isn't my program working? I was like, I would fix those first.
Yes.
I was like,
good place to start.
even if it's not what's causing your problem, it's going to make your build times and load times go way down. And
what do you think about the suggestion? I've heard this suggestion before. I haven't implemented it myself, but I know some developers who are so paranoid about this with type defs specifically that they'll create a library in their project just for their type defs. What do you think about that approach?
So I don't do that. What I do is I create a directory and I just drop them all in there.
So it's a
on
folder
disk?
on disk.
Yes.
So not even a library.
Not even a library.
Okay.
Because if you pull in one type def, then you pull them all in, which generally
Well,
who cares?
not
but-
true with a regular LVlib. So when you load a class, all of its methods get loaded into memory. But when you load a library, not all of its members get loaded into
Really?
memory. Really?
I thought if you load one member in a library, it immediately loaded
Nope.
everything.
Nope. Classes work that way. LVlibs do not work that way. That is a common misconception. You're
Okay.
giving me a look like
Well,
you're
I'm-
suspicious, but that's how it works.
Well, I mean, I am suspicious, but I trust you because you know way far more than me. So I am happy to believe that. I do need to test that now.
Yeah, go for it.
But I'll have to figure out how to test that and then go test it. But yeah, that's interesting.
Yeah. So that's why I like libraries so much for code organization. There's very few downsides. I think the circular dependency thing is the main downside that you got to watch out for with using libraries for code organization.
So now that you said that, I'm not opposed to putting them on a library. But the one thing I don't like is if I have like a DQMH module, right, and it has some type defs that it uses. Now I can't just pass the DQMH module out to somebody pass that folder. Now I've got to figure out what it depends on.
Yep. That's it.
And drag other
That's why I
files
said
out.
I haven't taken that approach either, but I know some developers that do, and I feel like maybe if it's a single LVlib that's just called project type defs or whatever, then throwing that along with a module is not that big of a deal.
Well, the other thing you could do too is just have it in the same folder as your module if it's generally used with that module and not any, and its callers use it, but like nobody else really uses it.
Yeah.
And then you could distribute that whole folder and it would
Maybe.
just be outside the library. But yeah, I ran into this because I had a really big actor framework project that I wrote, so I can't blame it on anybody else. But it was taking forever to build, and Steve Watts was like, well, do you have type defs in your classes? And I took every single one and dragged them out of the class, and all of a sudden it built in
Nice.
it went from like 20 minutes to like 2 minutes.
Nice.
And I was like, oh. So for like say a smaller, medium-sized LabVIEW application, how long does it typically take to build? Like if I'm seeing build times of like 10 minutes, is that like strange? Does that raise your flags that like that should be faster or?
I'm thinking about the largest LabVIEW application that I regularly deal with, and it takes, I believe, 30 minutes to an hour to build its top-level EXE, and that doesn't really raise flags for me. When I hear a story about once we start going into the multiple hours timeline, that's when I start to get a little worried about how long it takes.
Yeah, because ideally I would like to try to get my build test time and everything under like 5 or 10 minutes.
Yeah.
But yeah.
Now,
I'm pushing like 20 minutes altogether now till I do everything. So.
One thing I do appreciate that LabVIEW R&D does is I feel like they are regularly working and committed on reducing build times as part of their improvements to the LabVIEW editor and the developer experience. I'm always hearing about work that they're doing to reduce build times.
So I've got another question that related to that. So I have my CI/CD pipeline, and my build job like opens LabVIEW and then builds a project. Do the same things that cause slow build time, do they also cause slow load time, or is there something we can do about that to make your project load faster? Or?
There are definitely there's some overlap there because there's a lot of loading that takes place during the build of an EXE. But there's a lot of other stuff during an EXE build that isn't necessarily related to load. Things like relinking. Obviously, when you load, you're not relinking, you're just reading the linker info in your files. But when you build, you're having to relink. That can be something that takes a lot of time, especially if we have the circular dependency stuff like we talked about before. So, and that there's a million other things that AppBuilder does besides relinking, but like I said, I guess it would be like kind of like a Venn diagram. Like there's load is probably sitting here in the middle, but there's a whole bunch of other stuff on the outside.
Okay. So what are your tips for loading projects faster?
Okay, let's see. There's the simple stuff like making sure things are mass compiled. There's
so mass compiled. So if I have my CI/CD build server, should I mass compile it before I open the project? That would probably take way too long, right? So would you just mass compile it before you commit it? Is that the?
I will admit that I do mass compiles sometimes before I do commits. It's not something that I do regularly, but it's things like okay, this is going to sound kind of silly, but sometimes when I make a pretty significant change to my code, obviously I'll run my unit tests. Shout out to unit testing. But if I've made a big change, what I'll often do is I'll mass compile to see if there's any broken source that I wasn't aware of. That's something that your unit test may not find because, I mean, as much as we try to unit test, we might not be calling every single piece of our hierarchy.
No, I've run into that before.
Exactly. Yeah. So no, I wouldn't say I mass compile on it. Besides, the compile object cache is supposed to prevent us from having to do that, right?
Yeah, so if I'm checking it out on the build machine, it's going to have to recompile it anyway.
Yeah.
Okay. Yeah.
Yeah, the compile object cache is, I have found to be kind of a double-edged sword. It's really great, some of the stuff that it gives us. It really improves the CI/CD, the experience with source code control, the fact that we change a type def when we don't have to submit 100 changed files, right? That's a great thing.
That's amazing.
What's not a great thing is the fact that I would say 1 to 2 times a year, I run into a situation with a project where something gets weird about my compiled object cache, and I have to wipe it and recompile everything. I guess it's worth it because I'm still after all these years, I'm still using source only. I'm still using separate compiled code, but it can be frustrating to have to deal with those corrupted object caches.
Yeah. So for CI/CD, I just flush mine every time it's the start. It doesn't take very long.
I think like Jim Kring, I believe he does that too. Like I think that's a pretty common practice.
Yeah, that's like a very good first step.
Yeah, which is kind of frustrating because I know LabVIEW R&D their ideal is that we not have to do that. And so they put all this effort into, optimizing the compiled object cache only to hear stories like ours where we're like, well, we just have to wipe it every once in a while anyway, or we have to wipe it on every build anyway. And they're like, we want us to not have to do that. And so that's another thing that I think they're trying to do is improve the stability and the dependability of object cache.
I wonder though, if you're on a CI/CD machine where you're checking out new code, right, when you load LabVIEW, it's going to have to notice that that's stale and recompile it anyway, right? I mean, it's only recompiling the new stuff that things that have changed.
Yeah. So ideally, it would only need to recompile the changed files, which would be very fast compared to recompiling everything.
Yeah.
So ideally, they'd have all the bugs fixed, and we wouldn't have to be clearing the cache every time.
But yeah, I like the idea of rebuilding it anyway, because ideally, I would like to be able to get to the point where I do the CI/CD stuff on a fresh machine every time. Mm-hmm. Right now, I just have a VM running, and it's so whatever ran last time is still there. And so definitely worth cleaning it out to make sure that it's fresh.
Except earlier you said you also wanted to reduce your times as well. So those two things are competing. Yeah. Not to put you on the spot or anything.
No, that is a very true thought. Yeah, I know. Ideally, what I would like to do is be able to use Docker and just spin up a Docker container. But then every time I have to troubleshoot a CI/CD thing that fails, I'm very glad I have a GUI. So if I had Docker, I would not have that. Right. So, yeah. So that and just the learning curve and learning Docker has put me off to it. So
yeah, I know nothing about it other than I've heard people say there's a learning curve.
Yeah, it's a very big one. Yeah, virtual machines are not a terrible learning curve. I mean, you got to figure out how to set it up, but once you figure that out, it's just like a regular machine. It's just like booting another laptop or something.
You're exactly right. Like I figured out how to set up my base VM 7 years ago, and I haven't had to give it another thought.
Well, I have issues with Windows 10 just sucking up tons of resources, but I don't know if that's a VM issue or not, because I don't know. I gave up on using Windows for my own stuff anymore. I just run Linux and run Windows virtual machines, so I don't know.
I know. I listened to the podcast. I've heard you talk about that.
Okay, yeah.
Today's podcast is sponsored by SAS Workshops. We're passionate about helping teams create healthy, human-centered development processes. How? We guide you in crafting processes that put people at the center, be it your users, your developers, or your business stakeholders. Each of them isn't just a cog in the machine, but a co-creator. We help everyone create alignment so you're not just solving problems, but solving the right problems. Through working with us, you'll not only delight your customers, you'll also be able to communicate those wins to your management so you can get all the recognition you deserve. Want to learn more? Go to sasworkshops.com/contact and let's schedule a call.
I've been at NI for 24 and a half years now, and LabVIEW has been the focus of my career for almost that entire time. Nancy points out that I, Darren, love LabVIEW more than anybody else does, except for maybe Jeff K. So I love the fact that I've been able to base my career on this tool. I love the fact that I've been able to give to the community and help not only improve the product, but also provide, the presentations and the training that I've done. And within the past 3 years, been able to move back into a role to help support NI customers. My hope is that, and based on conversations I've had with people at I feel like there's a pretty positive future for LabVIEW. I mean, some people say one thing and then, you kind of wonder if they really mean it based on their actions. But I feel like and of course, with things at NI changing over the next year, who knows what's going to happen. But hopefully, LabVIEW continues to be a priority for NI. Obviously, NI has their big customers that they focus a lot on. And then there's some other people who kind of feel like NI has not focused on them as much lately. I know that's definitely something you've talked about before. All that being said, I just want to see LabVIEW users succeed. I just want to see LabVIEW adoption grow. I just want to see LabVIEW users get unstuck when they have problems and have a seamless experience when they use the editor. Those are the things that I want to try to help with. I want to do as much as I can to improve the lives of people who program in LabVIEW on a daily basis.
Very cool. So I have to ask, right? You've been around for a while and in R&D for a while. What are the biggest changes that you've seen to LabVIEW over the years from the back end?
Sure. So remember, I am a LabVIEW programmer just like you. So, I definitely wasn't sitting down, buddying code when somebody was changing the compiler or whatever. I feel like just a couple of ideas here. The parts of LabVIEW that have been written in LabVIEW have gone through cycles. I'll give you an example. When shared variables first came out in LabVIEW 8.0, they were built in LabVIEW. They were written as X nodes. If your listeners don't know what an X node is, I talk about it in my ludicrous LabVIEW presentation, but they were terrible. It was I would say shared variables in LabVIEW 8.0, most people would agree, was a colossal failure. And was it a failure because they were written in LabVIEW? In my opinion, absolutely not. It was a failure because they were written in a very untested feature of LabVIEW, which was X nodes. X nodes were being written at the same time as shared variables were being written, which were based on X nodes. So I sat next to the guy who was doing a lot of the LabVIEW programming. So imagine you are using a pre-alpha LabVIEW editor using a pre-alpha feature in LabVIEW to try to develop a customer-facing feature. It was kind of set up for failure. So so after that experience, though, there were some people who kind of wanted to pull back and said, look how terrible this was. We need to make more features in LabVIEW be written in C and C++. We need to step away from writing features in LabVIEW. And then, it might swing the other way. And somebody might say, wait a minute, we're selling this product for thousands of dollars. Yeah. We should be using it a lot more in-house. Let's write more features in LabVIEW. Mm-hmm. So that's one of the changes I've seen over the years, is just kind of a cyclical, let's write more of LabVIEW in LabVIEW. Oh, let's not write as much LabVIEW in LabVIEW. And obviously, as a LabVIEW enthusiast, I want as much to be written in LabVIEW as possible. Another thing I've noticed is the tremendous number of compiler optimizations that happen to the G code that you and I write that we will never, ever even think about. Like, you and I might write a VI that, has some for loops and while loops and case structures and does, some calls to functions and sub VIs. And we're looking at our block diagram. We're thinking, oh, okay, I can see, I'll even turn on execution highlighting and kind of watch, okay, I can see the flow of how this works. But when that code gets compiled down and turned into the intermediate language, and if we were to sometimes see what the graphical representation of what we wrote actually looks like, sometimes it's way simpler than what you and I have written, because the compiler has figured out ways to optimize certain parts of our G code that we would never think to do, because we're talking about just like a crazy sophisticated compiler of our graphical code. Yeah. So a lot of the times we'll what ends up executing is a fraction of the complexity of what we actually wrote, and that's something that we don't even see. I kind of equate it to, if, I guess this might be a little bit morbid, but a certain number of people die in car accidents every day, that we never hear about the millions of people that get to their destination safely. That's kind of what I think about, with the LabVIEW compiler. There's all these things that are happening behind the scenes that aren't even in our consciousness, because they just happen, and it's just efficient and it's cool. And that's one of the things that always struck me, because LabVIEW R&D has a tool that lets you see what the intermediate representation of your block diagram looks like graphically. So it kind of looks like LabVIEW, but it's not.
Is that like the defer code?
Yeah,
Okay.
you can visualize the defer code, and it kind of looks like a G diagram, but you're like, whoa, that's way simpler than what I wrote, because the compiler figured out ways to optimize out some stuff, and it's just super neat.
That's cool. Yeah, like some of that stuff, like maybe you've got some classes that have some dynamic dispatch or something going on, but it realizes that it's like hard-coded, so it's just, things
Exactly.
like that. Yeah.
Yep.
Very interesting. Cool. Yeah, I've seen some presentations on that process, and it's quite amazing what happens.
Yeah.
So, all right. So, what is your favorite LabVIEW feature over the years that you've seen?
In terms of editor features, I mean, Quick Drop's my favorite. It's got to be my favorite. I'm trying to think of just things in the editor that So here's one that I didn't think I would like, that I really did like, which was remove space. So we had control drag to add space for forever. And the developer in LabVIEW R&D who added remove space, his name's Craig. And he was like, hey, Darren, I want you to see this feature I'm working on. And we got that around LabVIEW 2015, I think. It's been a while. Sorry if I got the year wrong. But yeah, he showed me just like on his machine. He's like, look what we have now. We have remove space, control alt drag. I was like, well, that's neat that you got that done. I don't envision ever needing that though. And I was completely wrong. I use it all the time. I love it so much. Just it's such a convenient way to make our diagrams cleaner. Yeah,
because you can start really big, and then you're like, you leave yourself tons of space. You're like, okay, I don't need it.
Exactly.
Yeah.
I write a lot of scripting code, so I definitely know the whole like diagram stretching out for forever.
Cool. All right. So what's the most overrated LabVIEW feature?
All right. Execution highlighting. I never use it. I know very skilled LabVIEW developers who love execution highlighting. That is great. I'm not dragging on them, but like breakpoints and probes, like that gets me where I need to go. And I know I'm going to care about what's at that spot on the diagram. Why am I watching little dots go to get to that spot? And that is just my opinion, especially as a LabVIEW programmer. That is not an official opinion of NI or anything. But that's one that I'm like, why do people use that
also
thing?
retain wire values I found is really useful because
So
that's
great.
so much. Yeah, because I definitely found myself sitting there watching it go, and I'm like, wait. Especially when like what you care about is like on frame 10 or something.
Yep.
Of like you're like, oh, I gotta wait for all this. Or the probes that turn it on and off are really cool.
You'll like this. I was just having a conversation with Norm Kirchner the other day. And I casually mentioned, we were talking about that feature. I casually said the term after probes. He's like, after probes, what's that? I was like, oh, sorry. That was the R&D, like sort of quick, sort of nickname for that feature for retain wire values. We called them after probes. Yeah. And so Norm thought that was cool. And I think after probes is kind of a neat name. It kind of flows off the tongue better than retain wire values. But yeah, so if you ever hear me accidentally say that, that's what I'm referring to.
Cool. So what is the most underrated or undervalued LabVIEW feature?
Man, you're putting me on the spot, Sam. I didn't know you were going to have those questions for me. Let's see. Underrated features. We might have to edit out my long pause here.
I think we could probably do that.
Yeah, so let me see. Let me just think about just the things that I do in the LabVIEW. So, okay, I'll name a feature. I don't know if this counts as underrated more than underused, but the linking of tunnels and case structures and event structures, not enough LabVIEW programmers know about that feature.
That's really key.
Yeah,
That's
it
awesome.
is. It's really key, not only for just making your life easier as a LabVIEW programmer, but also to prevent bugs. Yeah. Like, you create a new case in the case structure, you forget to wire a tunnel, but it's set to default, and so it doesn't break your VI. That's something that the LabVIEW editor, I love when it does, and I think we need to figure out ways for it to do this more. It needs to break our code more. We need to have more things in the editor that prevent us from making mistakes. And like something really simple, like when you drag a case structure around code, and I have an idea exchange post about this, by the way. You drag a case structure around existing code. Do you know which frame it assigns to that? Do you know if it's true or if it's false off the top of your head? Quiz question for Sam.
Probably false because you're bringing it up.
It's true. So like a lot of the times you drag the box around, you just keep on coding your merry way without even thinking, should that be the true case or the false case? So things like that in the LabVIEW editor that can just sort of point us to like, hey, pay attention to this. Now, if we can break your VI, great, because you have to pay attention to that. A case structure for an enum that doesn't have all the enums in it. We break your VI. We need to find more places where we can break your VI to point you as the developer saying, hey, pay attention to this.
Cool. Yeah, there are some other features around. You mentioned the tunnels, like that people don't know about. Like the conditional tunnels are really nice.
Oh yeah.
The other one that I found that I forget who I was with the other day that they didn't know. Like if you have an output tunnel and you right click on it, you say replace with shift register. You can go and then click on the tunnel on the other side.
Yes.
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 Like that they didn't know that. They like dropped it and then rewired. And I was like, wait a minute. I was like, there's a quicker way to do that.
There is a longtime employee in LabVIEW R&D. He's been at DNatt for like 20 years now. That was his intern project like 20 years ago, was adding that mapping of the shift registers.
Yeah. So is there like a LabVIEW feature that like people just don't know about that everyone should know and use aside from the one you just mentioned?
Right. Let me think.
What pops into your head?
So there's one that was added, I want to say just a couple years ago, that I actually forget exists. And so it, like, just thinking about it now, I'm realizing, wait, there's a bunch of times where I should have used this and I forgot. So going back to the conditional tunnels you were talking about, so you've got a tunnel, an output tunnel on a for loop or whatever. Yeah. You can, build up an array there, or you can just output the single value, or you can concatenate things, right? Did you know you can concatenate strings? Like if you wire a string to the border, there's a right-click option to concatenate strings on that string so that it outputs a single string of all the string values concatenated.
I don't know if I knew that or not.
That was added like 2 years ago or something. It was like nobody knew about it. And so like that's one of those, it's like, I got to remember that that's there because I'm always ending up like making an array and then concatenating the array after or something like that. And I got to remember that we can concatenate on the tunnel now for strings.
So for strings, so Python, right, I can have an array of a string that is like a bunch of lines that I can break it on the new line character and iterate through them. Is there a way to do that easily in LabVIEW to take a multi-line string and turn it into an array of strings? Because I have not found an easy way to do that without like putting in a loop with regular expressions or something.
Yes, there's a VI called delimited string to 1D string array. I added it in LabVIEW 2019.
Is it in the palettes or you have to, okay.
Yeah. Just wire your string in, and it's got a delimiter input, so just make sure the line, the new line
feed?
character.
Okay.
Yeah,
and
it'll output the array. Yep.
Okay. Actually, you know what? I've seen that. I just didn't think to use it for that case. I use those VIs all the time. Okay.
Because there's one that goes the other direction too. I added those in 2019 because I'm like, I write this code all the time. I got to drop the spreadsheet string to array function and then wire the crap to it and trim the white space or whatever. So I just made VIs that wrap those. So it's just one VI.
Yeah. Cool. Yeah. No, that's good. I like it.
In fact, Stephen Loftus-Mercer sent me an email the other day. He's like, hey, you need to add this VI to LabVIEW. And it's the VI you just described.
Yeah.
And so I replied and I was like, dude, you've already got it. I put it to the VI that already ships with LabVIEW.
Very cool. One of the questions I always ask is, tell me about an experiment that you tried that didn't work out the way you thought it would, and what did you learn?
All right. So I mentioned I've got a long career at DNatt. And when I started at DNatt, I worked in what they called the Engineering Leadership Program. And as I mentioned, I worked on several different projects with different teams at DNatt. One of those teams I worked with was the team responsible for web content for tech support. So like knowledge-based articles and stuff like that. And I went to that team kind of like on a 3-month internship. And they were basically like, yeah, just, help us with knowledge-based entries and stuff like that. And one of the first things I noticed was this massive backlog of knowledge-based articles that needed to be edited before they could be published on DNatt.com. And so I was like, whoa, what's up with this? And they're like, yeah, we just got a bunch of these. And so it takes us several months from when somebody submits a knowledge-based article or somebody, proposes an edit to an article. It takes us several months to finally hit that in the backlog and publish it. Obviously, there was priorities. Like if there was something that was critical, it would get fixed. But there was this massive backlog. So they're like, yeah, just, do a couple of these per week. And, people just know that it's going to take months for their edits to go up online. And that bothered me a lot. There are different parts of my life where I'm type A and different parts where I'm not. And this is definitely one of those where I was type A. And like that backlog just bothered the hell out of me. And so I took extra time at work. I was like, we should just thinking to myself, that was my first mistake. Thinking to myself, we got to get rid of this backlog so that, people's knowledge of these articles can just go up within days after making them. Wouldn't that be great, right? So I spent several weeks just pour extra time, by the way, not part of my day job, extra time just pouring through all these things, hundreds, probably thousands of this backlog to get these knowledge-based articles. And they were about a bunch of different topics, not just LabVIEW, but like all the stuff that DNatt supported at the time. And after several weeks, I got the backlog like completely eliminated. It was at 0. And I went to the managers in the department. I was like, check it out. No more backlog. Now, as soon as a knowledge base edit comes in, we can publish it. And, it can go up within days. Isn't that great? They did not think it was great, Sam. They didn't like the fact that I was working on something that they didn't tell me to work on. It was a situation where I felt I was adding great value, but since it wasn't the value, since it wasn't someone else's value, it was of no value at all. And very shortly after I did this project, the team told me they didn't want me working on their team anymore. This was around the time where I was trying to find other things to work on at NI, because clearly the web team didn't want me helping. So that was a real shock to me, that this thing that I assessed value to, that I poured a ton of effort into, was valued by no one. Well, let's fast forward several years to 2007. I'm in LabVIEW R&D. I'm loving my job, working on LabVIEW, and it was LabVIEW 8.5, it would have been at the time. And I was working on lots of projects, and I started getting frustrated at how slow I was at programming in LabVIEW. I mean, I was fast, but I could have been faster. And so I spent an afternoon prototyping a tool that would allow you to drop objects in LabVIEW based on their name instead of in their location in the palettes. It took me an afternoon. And I showed a couple people. I was like, hey, check this out. Control space type of thing, and you can drop something in your VI. You don't have to do the palettes anymore. This project that I spent an afternoon on ended up taking everybody by storm, and ended up becoming Quick Drop in LabVIEW 8.6, which released in 2008. And I got to say, Sam, the collateral that I built for my career and for myself at NI in R&D, because of this afternoon project that I just kind of threw together, I could have never predicted that would have happened. Managers were impressed, and my teammates loved it, and everybody loves Quick Drop now, right? That was a project that I did on a whim that gained me this crazy notoriety in a positive way, compared to this project that several years before I spent so many hours on that people actively disliked, even though I felt it was something that had a lot of value. So the lesson I learned from all of this is that there's a lot of luck involved in just everything that we do, and sort of right place at the right time sort of things. When a 4-hour project on an afternoon can propel your career for several years in a row, whereas a nights and weekends for 7 weeks in a row project to help everybody's job gets a lot of scorn. That my lesson there was I guess we'll just see what happens.
So do you chalk that up to just pure luck? Because it seems like in one situation you showed some ambition, you went out, you did something, and it wasn't rewarded. In the other case, vastly rewarded, and just luck.
I mean, I don't want everybody's takeaway from this to be just what happens. You have no control over what happens, but it was a big illustration to me that in terms of an engineering career, you never know which things are going to take off and which things are going to crash and burn.
Yeah. Well, I'm glad that your first experience didn't teach you not to be ambitious. Because that would probably be the wrong lesson to take away from that. Because I can see where you're I'm never putting in any extra hours. I'll do just what I'm told. And that's probably not a great solution.
Not a great solution. Everybody should do the work they're getting paid for.
Yeah.
That was another lesson that I kind of got out of this. That team did not value at all this thing that I thought was valuable. So that was something I needed to take away and learn.
Yeah. So maybe before you go embark on these journeys, figure out if it actually is valuable to. Because that could be a lesson, what's valuable to you and what you think is definitely, as a consultant, that is very true. Because I go in and I see all kinds of problems and I'm oh, I can fix that. And they're yeah, we don't care about that.
Exactly.
We care about this thing over here.
Yeah.
And so if I went and fixed all the things that I wanted to fix, I wouldn't have a very long career as a consultant.
Exactly.
Yeah. Yeah, the trick is getting them to come around to your point of view and realize that, hey, maybe we should change that.
Sure, and a lot of that comes with experience, too.
And if you're really good at it, you make them think it was their idea. That's the real trick.
That's great.
Yeah, basically you just keep needling them and pointing out all the problems and holes and hey, do you ever have this problem? Yeah, I wonder why. I don't know. Could it be that over there? I don't know. Maybe it is.
That does remind me of one of my own personal proudest moments of reverse psychology, which was when, coming back to Quick Drop, so I invented this tool and everybody loved it. And it came time to name the tool. And so I'm not going to name any names, but a certain team at NI decided that the official name for this feature of LabVIEW should be Place Object by Name. That was going to be the name of that feature. Is like
They were not in marketing.
correct. When you press Control Space, you are invoking the Place Object by Name feature. So I really didn't want this to happen. I wanted it to be called Quick Drop. That was my name. And so there was this big meeting like to sort of finalize it. And in that meeting, I feel like I was able to successfully cause the room to decide that they thought that Quick Drop was the best name. And so we ended up getting the feature name Quick Drop.
Yeah.
I was pretty excited about that.
Yeah,
Way better than Place Object by Name. Oh my goodness. Please don't call my cool feature
The
that.
POB window. POV.
That's so bad.
Or PON, place object.
Yeah,
by name,
exactly.
POM
Yeah,
window.
and we got a bunch of pod people programming LabVIEW. No, this is Quick Drop, much better.
Yeah, no. Yeah, I quite like Quick Drop now. I have to say I was a late adopter.
And there's some people that, I mean, Jeff Kodosky doesn't use it. I mean, it's a tool to help you program faster, and if you don't want to use it, you don't have to use it. But I think it helps a lot of people program faster.
Well, the brilliance of Quick Drop, even if you don't use Quick Drop, is the shortcuts.
Oh yeah.
Those are brilliant. Like, even if you don't use Quick Drop itself, learning a couple shortcuts,
Yep.
that's huge.
And those are only there because I, as a LabVIEW programmer, I didn't have a way to hook into the LabVIEW editor at the time. Like, that was all C code, right? But when you press Control Space, you're in my world. You've got a VI that's running. So now I've got a way to run VIs from my VI, and that's how we got the object, the control key shortcuts.
Yeah. So for anybody who doesn't know, you can create your own Quick Drop shortcuts.
Absolutely.
You probably have a presentation on that. I know Tom McQuillan has some presentations
I do.
on how to do those things too.
I have a presentation called let's see, what is it called? It's called, you're going to edit this out once I remember the name. Don't wait for LabVIEW R&D. Write your own LabVIEW features. That's the presentation. And in that presentation, I talk about all of the hooks, all of the G hooks that LabVIEW programmers can hook into in the editor to write their own features. And Quick Drop plugins are one of them.
Yeah, and another one too is not quite the editor, but VI Analyzer is another one. Right?
I talk about that too because you can write your own VI Analyzer test that will not only inspect your code, but make changes to your code too.
So if you're a listener and you like all those things, kudos to Darren right here.
DNatt.org. That's where you can learn about all of it.
Perfect. Great. All right. Well, it's been a great conversation, Darren. I quite enjoyed it.
This
Covered
has
a lot
been
of ground.
Very enjoyable.
Yeah, I think I enjoyed it, and hopefully all our listeners will as well.
This
So
is
I think
great.
there's a
Thanks
lot
for
of
having me on
little
the
nuggets.
podcast. It's been long enough. I've been wanting to be on here for a while, so this is
Very
great.
cool. Great. Thank you.
Sure.
That's it for today's episode of the LabVIEW Experiment. Thanks for listening. If you have any comments or questions, head over to thelabviewexperiment.com and drop me a note. And don't forget to subscribe to the podcast and follow us on Twitter and Instagram @TheLVExperiment.